This video is looking at section 1.3. In this section, we're looking at just problem-solving strategies. Okay, so at this point, we haven't really reviewed any algebra or things like that. So we're mostly going to be approaching the problems using some kind of just intuitive, guess and check, trial and error type approach. All right, there is a general process you sometimes learn about called Polya's four-step problem-solving process that's not bad to think about. First, you really want to read the problem. Just a quick read. Don't try to hang on to the specific information, but just get the gist of it. Think about what you're given and what you're asked to find. Okay. That's understanding the problem. Second step, try to think about how you're going to attack the problem, what you might try to do. So you could make a list of the possible outcomes, maybe draw a diagram, use trial and error. Think about something that you already know how to solve that's similar to this. And then if you were up to speed on, using some geometry or algebra if necessary, you might do that. Then try it. Try carrying out the plan. If it doesn't work, try something else. Don't just give up. There are many ways to solve a problem. Just be persistent. And then check your answer. Kind of think about the words of the problem, answers you got, see if it makes sense, see if it's reasonable. Okay? So I wanted to just look at a few problems here. So this one, here's the problem. A gardener is asked to plant 8 tomato plants that are 18 inches tall in a straight line with 2 feet between each plant. How much space is needed between the first plant and the last one? Okay. So with that one, that might be one that I would actually just try to draw the situation to try to understand it. So let me think about that a little bit. So 8 plants. So I might just think about my plants being planted. That's 4, 5, 6, 7. There's my 8 plants. They're 18 inches tall. I'm going to plant them in a straight line with 2 feet in between each. So that's 2 feet there. 2 feet there. Between each plant, there's 2 feet. Okay? And then it says, how much space is needed between the first plant and the last one? So I actually have it all drawn out so I can see what to do. And that would basically be to take all these 2. So there's 1, 2, 3, 4, 5, 6, 7 of them. And you're kind of assuming the plant itself doesn't take up much space. That 18 inches is how tall they are, not how wide they are. So that's really just extraneous information. So it looks like I could just do 2 times 7, or just add up 7 2s and get 14 feet. That symbol right there, by the way, means feet, if you've never seen it. All right, now they're trying to get us to come up with a formula for the length needed for any number of plants. So you might want to kind of do a little pattern exploration. So, if we had 2 plants, then we'd need 2 feet. If we had 3 plants, then we would need 4 feet, okay? 4 plants, we would need 6 feet. Do you notice how we need, if there's 4 plants, we only have 3 2s, okay, giving us the 6. So this is like 2 times 2, this is 2 times 3, this is 2 times 1. All right, and then we did it with 8 plants, right? Okay, so there were 8 plants, but there were 7 2s. So we did 2 times 7. So when there was 8, we just had 7 2s. So 2 plants, 3 plants, 4 plants. Here's 8 plants, 8 plants. So it looks like if n were the number of plants, number of plants. That symbol means number. If n were the number of plants, then we would need 2 times 1 less than that. Okay, right? Because when there were 8 plants, we did 2 times 7. When there were 4 plants, it would be 2 times 3. So it looks like 2 times n minus 1, and if you know about the distributive property, that would be okay also. So you would say 14 feet for part A, and you'd say either 2 times the quantity n minus 1 or 2n minus 2. And you're letting n be the number of plants. All right, let's try another problem. So here we have campus group setting up a rectangular area for a tailgate bash. Okay, so I'm just thinking about a rectangular area for a tailgate bash. They have 100 feet between 2 roads to use as the width and 440 feet of fence to use. What length will use up the total amount of fence and enclose the biggest space? Okay, so let's make sure we understand it. So rectangular area for a tailgate bash. Okay, so I'm thinking about this being a road here and this being a road here. So they have 100 feet between 2 roads to use as the width. So that would be 100 feet, so would that. What length will use up the total amount of fence and enclose the biggest space? Right, so I guess that means we want this area to be as big as possible. Okay. All right, so there we may want to just do some guessing and checking, some trial and error or something like that. So we know we've used up 200 feet of space here between the 2 rows. I'm kind of assuming that the fence will go around all 4 sides. Okay. Even the sides where the roads are. Okay. So if I assume that, then my 440 feet of fence, I've already used up 200, and I'm down to 240 feet left. And it's a rectangle, so that will have to get divided by 2. So I'd have 120 there and 120 there. All right, so it seems like 120 feet is the answer then. What length? 120 feet in length. That would use up all the fencing. All right, now I did make the assumption that the fence had to be on all 4 parts. I'm thinking about people bringing dogs to the tailgate. They don't want them running out into the roads. Okay. All right, let's see about this one. As part of your duties as the new hire at a job, you're put in charge of buying 12 door prizes for an end-of-year staff meeting. You've got a total of $110 to spend, and the boss is thinking that insulated drink cups and smartphone stands would make nice gifts. If the cups cost $11 and the stands cost $8, how many of each should you buy? Okay, and the idea is we should spend as close to 110 as possible. That's the purpose of this sentence here, which actually this is kind of true. Okay. All right, so we're just buying either drink cups, and those are how much each? Like, as I read that, I wasn't really trying to hang on to the specific information. I was just trying to think about how I'm going to approach it. And then smartphone stands, and they're $8, okay? And I want the total to turn out to be 110. How many of each should you buy? Okay. All right, so we might just do a kind of a guess and check approach. All right, and let's see, 12 door prizes. So whatever we put has to add up to be 12. So why don't we try 6 and 6, see what that turns out to be. And here is what the cost would be over here. Let me raise that up a little bit. Okay, So if I do 6 drink cups and 6 smartphone stands, then wouldn't that be 6 times 11 plus 6 times 8? And if I did that, that would turn out to be, I'm going to my calculator right now. So that would be 66 plus 48, which would get us to 114, okay? But I only have $110, so I know I need to do less than that, but I want to get less than that, but as close to the 110 as I can. All right, so let's see. So something less than that, but it's only $4 away. So maybe, let me try 1 less drink cup. I still need it to be 12 things and 1 more stand. So that would be 5 times 11 plus 7 times 8. So that would be 55 plus 56. And that would get me to $111. All right. So that's really close, but I need it to be 110. So what if I did, okay, if I did 1 less smartphone stand, that would knock that down to 106. 1 more drink cup, that would make it too much. All right. All right, so what if we tried wow, I don't know. Let's try 4 and 8. You know, believe it or not, since I know how to do this algebraically, sometimes I'm not the best thinker when it comes to doing it just using common sense. Let me try it. Let me try 4 times 11, which would be 44, plus 64. Oops, that's not true. 44 plus 64. That'd be 108. Okay. All right, I needed them to add up to be 12. So that made sense. Let me try one more thing just to make sure I'm not messing up. Let me do 7 of the drink cups and 5. 7 of the drink cups and 5 of the smartphone stands. 5 times 8 was 40. That'd be 117. All right, so I can't go over budget. So it looks like what I would need to do, I couldn't go over budget, so I can't do the 55 and 56. So it seems like I would need to use 4 drink cups and 8 smartphone stands. Okay. Interesting. All right, I'm gonna, you don't need to know this right now, but I'm gonna go ahead and work this using a system of equations. I'm gonna let x equal the number of cups and y equal the number of stands, and then I'm gonna do the total of those two has to be 12, and then I know 8 times each 11 times each cup plus 8 times each stand, I want to equal like 110 if possible. All right, so this is called a system of equations. Again, you don't really need to know how to do it this way at this point, but I just thought I'd check my thinking. So what I did was I multiplied this equation through by a -8 everywhere. And then when I add the two equations, I get that 3x would have to equal whatever 110 minus 96 would be, which is 14. And so x would need to be 14 divided by 3, 14 divided by 3, which is 4.6 repeating. And I can't go over budget, so that's why it turns out to be 4 cups and then the 8 smartphone stands. Okay, this idea right here is using algebra, and you don't really have to be able to do that. But once you know algebra, sometimes it's hard to feel confident about your answer when you're doing trial and error. Okay, but trial and error is a very effective technique. All right, let's try another problem. You've graduated from college, ready for that first real job. You have 2 offers. One pays an hourly wage, $19.20 per hour, with a 40-hour work week. And you wind up working for 50 weeks and get 2 weeks paid vacation. Second offer is salaried, offering $41,000 per year. Which job will pay more? So salaried is $41,000, done. Okay, and the other one is hourly, and you get paid $19.20 per hour. Okay, and so 40 times the 19.20 would give you 768, and that would be for 1 week. You work for 50 weeks, so we'll multiply that by 50. And that means 768 times 50, that's 38,400. And you get 2 weeks paid vacation, All right, so they pay you for those 2 weeks. So I should have included that here. Okay, so I'm going to include that here. I'm going to go back and modify that. 52 times 768. And that gives me 39,936. Which one will pay more? All right, so it looks like this guy actually pays more. All right. All right, let's try question number 5. This problem says that we might need to use a calculation of some sort. All right, well, a nutritionist say that you need to burn 3,500 calories while exercising to shed 1 pound of excess body fat. An average-sized person can burn about 100 calories while walking a mile at a fairly brisk pace. How many miles per day would an average person have to walk in order to shed a pound of body fat in a week? Okay. So 3,500 calories enables you to shed 3,500 calories is 1 pound. I'm just going to jot down a few things so I can keep it in my head. Equals 1 pound of body fat. 100 calories every mile. Okay. How many miles a day would an average person have to walk in order to shed a pound of body fat in a week? So to shed a pound of body fat in a week, they would have to have burned 3,500 calories. So they need to burn, I'll just jot that down for myself, must burn 3,500 calories in 1 week. Okay. And then it says they can burn 100 calories while walking a mile at a fairly brisk rate. So let me take the 3,500 calories, because I'm trying to lose a pound of body fat in a week, and to lose it I'd have to burn 3,500 calories. And if I divide 3,500 calories by 100 calories per mile, okay, then I'll wind up getting 35 miles. Okay. So I'm thinking the answer, this right here is what I think the answer would be. So then I can work backwards to check it. 35 miles, that would burn 3,500 calories. That would burn 1 pound of body fat. Okay, so 35 miles, that would be what I would have to do in a week, actually. Okay, so let me erase that. That's in a week. All right, and so now let's double check that we answered the question. It says how many miles per day? So 35 miles in a week checked out, okay? But I didn't need that as my answer. I needed how many miles per day, okay? So can you think about what we would do there? There's 7 days in a week, so if we divide by 7, we get 5 miles a day. So that's my final answer, 5 miles a day. All right, so you're going to be having some problems that are kind of unusual, that don't have a fixed process that you have to use to solve it. They're not going to be ones where you necessarily need to use algebra. And you just need to be persistent. Just do it, double check it, and see if it seems like you're using the information in a logical way, and then just figure out a way to double check it. So my final answer on this one was 5 miles a day. Let me erase this and this. And I wound up with that being my final answer. Okay. All right, let's see this one. All right, one more. The grade in Lee's history class will be determined completely by 3 tests, each worth 100 points. She scored a 78 and an 84 on the first 2 tests, but still hopes to get an A, and an A requires an average of 92. So we want to know what she would need on the 3rd test so that these would average 92. So I know to average something, I add them up and I divide by the number of tests, but I want it to be 92 when I'm finished. All right, now here's a problem where if you know some algebra, you might approach it using algebraic techniques. Like if I were trying to solve that algebraically, I know to multiply by 3 on both sides because that would knock the 3 out. So 92 times 3 tells me the total number of points that she would have to, her 3 tests would have to add up to be, which would be 276. So then I could say, all right, so if I took away 78 and took away the 84 she already earned, that would mean that she would need a test grade of 114. So really, it's just not possible. Not possible. Okay? Now, you don't really have to know algebra to do that. What you could have done is tried putting 100 in there. Like if you're doing it using guess and check, still thinking this, try putting 100 in there. If you put 100 in there, the 100 plus the 78 plus the 84 turns out to be 262. And when you divide that by 3, the average turns out to be 87.3%. Okay? So that's another way to see that it's not possible. Okay? All right, so when you're working through the homework on 1-3, there's going to be multiple approaches you could use. Just try to use some of your common sense and be persistent if it doesn't seem to work well the first time. Okay, so read through this right here when you get a chance. Problems can be different. There's not going to be like a set thing that works on every single problem. So some things to keep in mind. If it talks about a rectangle or like the plant problem, something that you can draw, a drawing almost always helps. Okay. When you're reading a problem, sometimes it can be overwhelming. There's just too much information. So don't try to hang on to all of that. maybe what you can do is just write down the numeric information in the problem as you read it. That starts getting your brain thinking, and you're starting to organize your thoughts a little bit. Okay? I usually write down what I'm given and what I need to know. That's like one of the strategies I use. Sometimes making a chart, okay, especially if you're using trial and error. And then don't assume that you're just going to magically know how to do it. A lot of times you have to read it several times before you even know how to get started on it. So don't be afraid of making a mistake. Don't be afraid to try, okay?